Hello everyone, hope you're okay. Everyone is okay. So today I'm going to demonstrate using the help of some code snippets built on Python as how the team filters, which I'm pretty sure you have all used Microsoft Team during our work, and we have all done the video conference in which we have the scenario where we have to blur our background because we are not comfortable sharing our background because most of the time it's messy because right now we are working from home mostly. So the idea is to replicate the same functionality in our Python code uh, with the help of Python, obviously, and OpenCV and MediaPipe. These three tools I'm going to use. I'm going to demonstrate. Okay, how are we going to replicate that functionality? Okay, that helps us blur the background, or if I want to add an image in the background, like for example if in Microsoft Teams we also have an option to replace our background with the office background so it looks more professional way. So let me explain you what is OpenCV. OpenCV is basically a library that is responsible for image processing and image manipulation. Like for example, you see Photoshop. Okay, that's big. Uh, you can say that not a comparatively good example, but you get the idea. Photoshop is basically responsible for image manipulation and image alteration. So behind that, OpenCV like library is being used. For example, MS Paint, Microsoft Paint. That's a relevant example. Microsoft Paint. I'm pretty sure we have all used Microsoft Paint. So in that we have some basic tools like brush. We have a tool to morph some shapes like circle, square, rectangle, to create an image out of it, and we can even save it, and so on and so forth. So that is the basically need or two that is basically what we require OpenCV to perform the same operation here in our functionality. And finally we have MediaPipe. uh, it's better to show what is MediaPipe. MediaPipe is basically um, Google's library, AI-based library, which has different sort of, you can say, models bundled up into a single library. Python is built on Python, C++, and different in Java. So in that library, we have different sort of models. Like you can see that we have object detection, image classification, image segmentation, interactive segmentation, gesture recognition, hand mark detection, image embedding, face detection, face landmark detection, post landmark detection, face stylization. Sorry for that. And as well as some models related to text and audio. So in all these models, I'm not going to explain one by one each of them because it's irrelevant for this session right now. So I'm going to only focus on image segmentation. That is what we need. As you can see in this photo, in these two pictures, the original photo and the segmented photo, the difference is that the portrait of the person, of the man in the picture, has been masked. Okay, that's the word we're going to use, mask. So it indicates that in this entire picture, this person has been masked as a segment. So we have one segment that is a person. There can be different segments. It can detect, this model can detect more than one segment in a picture, but typically in an ideal scenario, we are the only one in front of the camera most of the time in conference and video conference, or any mostly video conference. So in that only scenario, we're going to assume that we are the only one in front of camera, so there's a chance that only one segment will be generated. um, I'm not going to go into detail. Let's cut to the chase, and we should start coding. Before starting our code, writing our code, I'm going to install all the libraries. First I need to install OpenCV Python. Oh, I have already installed everything. Okay, it's in my laptop it's pre-install everything, but just to demonstrate, I'm going to rerun this command, hit install and MediaPipe. Yeah, very clear. I'm going to create main.pay. In that, I'm going to import CV2, import numpay. Yes, that's my apologies, I forgot to mention this, but numpay is also required for image processing alongside OpenCV. Whenever you're using OpenCV, you have to use a numpay as well, because numpay is basically mathematical manipulation library, solely and mostly responsible for n by n matrix manipulation. So again, continue for the run, MediaPipe and as MP. So what we're going to do first, we're going to create an object of camera, cv2 dot video capture this. Okay, so now what this object did is it captured the device, which is camera, on the index of 0. Simple as that. While true, I'm going to capture the camera dot read. Simple as that. Now this returns two values. One is actually status, which we can ignore by setting it in underscore variable, and second one is frame. Now in frame is the actual responsible for displaying. This variable has all the content, all the, you can say, the actual picture. Okay. cv2.show, this function is responsible to display the picture. Let's give it a name, filter, and after that I'm going to write a code that will wait key, just a second, I'll explain you in a minute. Wait one, and oxf is equal to q, and that is going to break. So now what I did, I basically stated the command that whenever I press q, the program will stop and the camera will be released, and all the windows that are opened by OpenCV should be closed or destroyed. So if I run this code with the Python debugger, oh, pretty cool. So if you can, as you can see, now this program is now able to display the camera result. Seems fair enough. Now continuing, what I'm going to do first thing first is I'm going to create an object of MediaPipe solutions, mp underscore solution is equal to mp.solutions dot selfie segmentation, and selfie segmentation is equal to mp dot selfie just a second, solution dot, okay, what was the sorry, my bad, solution dot selfie segmentation. So now we have the object of the model of selfie segmentation. So we can do this is process the frame into the model, and it will return a result which we can set it into the mask variable, result dot selfie segmentation. If we check what is inside, okay, something is missing. Selfie, okay, my bad. Okay, my bad, it's a segmentation mask. Segmentation mask. Okay, so now as you can see that the MediaPipe has done the processing of my image, which is frame, and in the result it gave me the mask. Now what is mask basically right now, as what you see right now in the screen is the white part is basically, you can say that that white part is cropped out or highlighted as indicating that, yeah, I can detect this thing, this person is somewhere, and this is his silhouette or outline. Explain, yeah, I remember now. Just a second. So typically this was the step. Okay, this was the process. This is the process that I am thinking to implement. First thing first, I'll take the original image. I will crop out the person inside the image, which is right now I'm going to do in the next step. Then I will take again the original picture, blur it out with that person, because in the original person I don't care if it's blurred out or not, because we already have a picture of a person which is cut off and it's in original state without blur. And then what I'm going to do, I'm going to combine this image with that image. Okay, so that's the process what we are going to do. So if I'll just cut it off and close it. Now the next step is to, okay, let me just look at it, my apologies, just to remind. Now we have to crop this person out of the image. So what I'm going to do is I'm going to save this mask. Okay, first thing first, let me put this into a separate variable. Ing is equal to frame. Now what I'm going to do is I'm going to crop image is equal to cv2 dot cv2 bit twice, and this input image input image and mask. So now I'll explain you in a moment what exactly am I doing right now. Okay, yeah, sorry, my bad. So how do I explain this? Let me open the paint. You see, right now the result that we have received from this variable, inside this variable, is basically it's a matrix. It's a 2 by 2 matrix, and let's suppose the black part is 0 and the white part is 1. So 0 1 0 1 0 1 0 1, that is how it is going. It is formed in that structure. Now what we have to do, we just like we typecast in typical programming language like any other, JavaScript, C#, C++, Java, we convert a string to integer, integer to string. We are going to convert this matrix, which has a different standards of number to represent the image, into a different set of number that represents different set of image. Like we have different color palettes like RGB, we have hex, we have HSV, we have GBR. So these are different sets of color palettes, and each is represented by different set of color coordinations. Like for example, in RGB, each node has inside a set of 3. Okay, red, let's suppose red is 25 and green is 25 and blue is 35. Okay, and in RGB format, 255 is basically the max color palette, which is white. So in RGB it is set, the matrix is set in such format where one node has a set of 3 having color RGB. Okay, how do we set this? Erase. So coming back to this, now what is happening, as I already told you, that this is right now in a different typecast. Now we have to convert it into RGB. So for that, what I'm going to do is going to call mask. Now I'm going to multiply all the values with multiply by 255, because again I told you that 255 is the max. And as type, and I will convert it into np.utf8, and then I'm going to use OpenCV cv2 dot convert color with the source. I will give the source, and I will convert it into what was the code, mask gray, just a second, cv2 dot gray, cv2 dot color gray to RGB, because since the source picture is in black and white, so we will indicate into gray to RGB, even though in the conversion it's still black and white, but the color convention, the numbers that represents the image is different now. After that, what I have done is I have used the bitwise operator in CV2. It is in NumPy as well, but I prefer to use as CV2's bitwise operator. Just CV2. Now what it does, basically, if you remember in the computer science, we use different sort of gates: AND gate, OR gate, or AND gate, OR gate, NOR gate, XOR gate. So it's the same thing. If I open AND, OR, NOT. So what is actually doing it is that, since as we discussed, as I told you earlier, is that in the matrix, let's assume the black part is 0. Okay, so what, let's suppose black part is 0, this is 0, and the rest of the part which has mask is basically 1, like this. I'm giving a rough sketch. Let's assume all these ones are in right alignment and in the right node, and the rest are 0. You get the idea. I'm not going to draw it everywhere, so you got the idea. So what happens is that in the bit operator, both conditions have to be matched. That's how it's going to display. So what happens is that, since this is the mask, these are the ones of my silhouette, of my layout, and I will mash or add, or should I say use AND operator for both of the image. So what it will does is that it will check each point of the matrix with other picture, from one picture to another picture, and it will check that the source image on the matrix first index to 0 index, x-axis and y-axis of the 0 index, has a number, but in the mask is 0, so it will nullify that pixel. So keeping that in mind, it will replicate the entire process throughout the picture incomplete. So as a result, it will only show my part and exclude the background. So the background will be black, and only my face and my body will be visible, and I'm hopefully the camera as well, for some reason, because camera is also considered as inside the segment. Yeah, here you go. So as you can see, since I'm close to the mask, I guess if I stay away, no. for some reason it's also detecting the mask. So as you can see that my background has been erased, has been removed, and only my face and my body has been detected. So which is good, which is in the step, in the, where did that picture go? Yeah. So now this process is done. Now we have to do is we have to blur this image out, the original image. So I'll take the input again, and I'm going to create another variable, blurred image, and I'm going to use cv2 dot blur, and I will give you the source, and I will give the intensity of 80 by 80. You can also choose like 10 by 10, but it will not show the effect. It will be blurred, but it will be very less intense. Why are we going? Why are we giving a parameter as a tuple, a set of two? Because one will do the blur in x-axis, and the other will do the blur in y-axis. So adding them both will result a blur of 2 by 2 matrix. And we can also give what was the sigma? Yeah, what was sigma? Sigma has to be 0. I'll explain later what exactly is the sigma. So if I preview this image, as you can see, now the whole picture is blurred. Okay, and if I blurred picture, and if I show both of the processed image side by side, here's the first, where's the other one? Oh, sorry, my bad. It has to be cropped. So here you go. So as you can see that this is the blur picture, this is the crop picture. This blur picture was basically the original picture that I just did the blur effect on, applied the blur effect, and this was also an original picture which I put the bitwise operator and eliminated the background. So now what I'm going to do is I'm going to add this cropped out picture of mine into this blur one. So again, I'm going to just going to bitwise the crop, and I'm going to add combined image is equal to cv2 dot bitwise, and same logic applies. What I did for cropped, I'm going to do is for combine as well. So I'm going to use, what I'm going to say that, hey, combine, sorry, combine, it will be add, not bitwise, add. So what I'm going to do is add this blurred image with crop image, and I'll display the crop image, and let's see what the result is. Okay, there seems to be a bit problem. Okay, so yeah, I know what the problem is. See, since we are adding an image on an existing image, so the cropped out image was already existing in the blurred image. So since I overlapped it, the colors amplified. So that's why you can see my layout is very bright. So what we have to do is we have to crop out my layout from the blurred image and then add it. So for that, what we can do first, we have to invert the mask. I'll explain why I'm doing this. Invert underscore im mask, inverted mask, that's right, inverted mask is equal to cv2. Okay, what is the problem? Inverted mask, bitwise mask, okay. Mask. Okay, sorry, my bad. No. Okay, so as you can see that what I did, okay, let me just show you that part as well. In the first masking, my layout was white and the rest of the background was black. In this, what I did, I inverted with the help of not operator. What not operator does in typically, if in any programming language, if you put exclamation mark in any boolean variable, so if it is true, it would convert it into false. If it is false, it would convert it into true. The same applies, same logic applies in the matrix, in the 2 by 2 matrix. So what happened is that wherever the white parts were, it converted into the black part, and then the vice versa. And what I did, I applied that mask. I said that, hey, wherever the white part is, let it remain the same, and whatever the black part is, remove it. So what happened in that case is that I got the background where it doesn't show my layout, but instead it shows the background. Okay, if I put my layout and the background side by side, cropped image, and this side by side, you will understand what I'm exactly explaining. Just a second. Cropped. You see, on the other hand, on the one hand, you can see my layout without the background, and in the other picture you can see the background but without my layout. So we're going to combine this picture, but before that I'm going to blur this as a background blur, so we can get that background blur effect. So we already have that variable. I'm going to show you this. Okay, so why, oh sorry, my bad. Copy, paste, and this, that. So as you can see that my background is blurred. Now I am going to apply this picture with that. So we already have it, we just have to display it. Keep it on, filter, and here we go. It's a bit of you can say that it's a bit of glitchy. I have to do a little research what is the problem is. As you can see, this outline, it's purely visible, which is kind of annoying. As you can see that these red glitches, I have to check. It's just a matter of how I'm adding these two pictures. That is responsible of the glitch, as you can see. But overall, as you can see that my background is completely blurred. The overall effect is working fine, which we wanted to do, which we intended to aim at. There's another thing that we have is that you also use office background image. This is this one. That looks reasonable. That looks easy as. I can see. Why is this one? Grab it. I can find a proper picture. Let's go this one. Okay, this one. No, I'm doing anything. Okay, let's go if I office and add in this to this. Okay, now we have background image. So we're going to instead of blurring the background, applying blur effect, we're going to apply the image effect, image filter effect. That will completely remove the background and put it another image into it. So for that we need to background office background is equal to cv2.read and read. Okay, I'll give the file name office.jpg, and then instead of background, blurred and background, I'm going to commit that out, and then I'm going to, I still need to revert it, I guess. We'll check. Yes, we need to. Instead of input image, I'm going to use office background, and I'm going to commit that out. Maybe I can just, yeah, we can come that out and go to okay, what's same size. Okay, sorry. So since the dimension of this picture is different than the dimension of the frame that we're getting, so we need to first resize this background image. Office background is equal to cv2.resize. We're going to give the source. Sorry, we're going to give the source office background. Office background, and the size will vary from what was the syntax? Is there anything? I guess it was frame dot shape. This is the height, and this is the width, and this is the width. This is the height. So if I run again, and voila! As you can see now, it's clearly that my background is removed with office background, which looks pretty neat. So yeah, this is the overall code. You can check it from the GitHub. I will share the link of the GitHub. You can download it, play it with yourself, do the experiment. So yeah, that's it. Thank you for watching. See you next time.